Hi students, our next chapter is work and energy. It's a simple chapter. We have to discuss what is work and energy. Then an equation for work and two equations for energy. Then what is power? Okay, let's start. What is the difference between scientific work and actual work? In our daily life, it is a common word. Work is a common word. We can do a lot of works and many works that we have to do. Work is a common thing in our daily life, but scientifically there is some difference. Okay, so what are the differences? We have to discuss that difference. What are the difference between working hard and scientific work? To do work scientifically, it needs to satisfy two conditions. Two conditions. First one, a force should act on an object. A force should act on an object. A force is required and the object must be displaced. The object must be displaced. So there is a question. Is this a work? Yes. I applied force on this gesture and it moves. It displaced. So it is a work. But I pull this wall very hardly. I pull this way hard. I pull this wall very hardly. But it doesn't move. So it is not considered as a work. I wasting my energy to pull this wall, but it doesn't move. So that is not included in a scientific work. To satisfy scientific work, that the object should be displaced. Okay, the object must be displaced. These are the conditions. Okay. If there is no displacement in an activity, scientifically it is not considered as a work. The work is zero if the displacement is displayed. Then, for example, a person pulls a wall but doesn't move, then it is not a work. Okay. So, if there is a displacement, then we can consider that as the work. Okay. Then define what is work. We have to define work. Work is defined as a force required to move an object to unit displacement in the direction of applied force. Work is defined as the amount of force required to move an object to unit displacement in the direction of applied force. We can also define it as the product of force and displacement. Work can also define as the product of force and displacement. Okay, W is equal to Fs, F into this, force into displacement. Calculate the work done. If force is 10 and displacement is 5. There is a question. A person moves this duster into 5 meter by applying a force of 10 Newton. Okay, so find the work done. Work done is equal to F into S. 10 into 5, that is 50 joule. Unit of work is joule. 50 joule is the answer. Define 1 joule of work. Unit of work is joule. Define 1 joule. 1 joule is the amount of work done on an object when a force of 1 Newton displaces it by 1 meter along the line of force, along the direction of force. 1 joule is equal to 1 Newton into 1 meter. Work is equal to F into S. So put all these things as 1, as unity. So 1 joule, the unit of work is joule. So 1 joule is defined as the amount of work done to move an object into 1 meter by applying a force of 1 Newton. Okay. 1 joule is the amount of work done on an object when a force of 1 Newton displaces it by 1 meter along the direction of force. That is 1 joule. Put all these things 1 in the equation of work done. Then we will get 1 joule. Okay. Then what is energy? It's another topic in this chapter. Energy. Energy is the capability to do work. It is same as that of work, but there is a slight difference. Energy is the capacity to do work. Equations are same, but the capacity is known as energy. An object having capability to do work is said to possess an energy. Any object that can able to move an object said to possess an energy. By doing work, energy transferred from one object to another object. Energy is transferred from my hand to this board, this duster. So, when we doing work, energy is transferred from an object to another object. Then define the relation between energy and work. Define the relation between energy and work. The energy possessed by an object can be measured in terms of the capacity to do work. In terms of the capacity to do work. Therefore, it is same as that of the work. Energy and works are same. The units are same. 1 joule is the energy required to do 1 joule of work. There is only slight difference. It is the capacity. The capacity or capability is known as energy, and we can measure it by work done. Okay. Then what are the different forms of energy? There are a lot of energies are available in our universe. Kinetic energy. We can classify this energy into different groups. That is kinetic energy, potential energy, heat energy, chemical energy, electrical energy, thermal energy, etc. So these are types of energy, different forms of energy. But in this chapter, we have to study only kinetic energy and potential energy. Others are common. Okay, kinetic energy and potential energy. First one, kinetic energy. What is kinetic energy? It is the energy possessed by an object due to its motion. It's the energy possessed by an object due to its motion. For example, or speeding car. A car can move an object by hitting this object. So it possesses an energy and it can do work on a person or an object in front of that car. Okay, so that is a speeding car have kinetic energy. The kinetic energy of an object increases with its speed. Kinetic energy depends on its speed. When speed increases, kinetic energy also increases. It is the equation for find kinetic energy. Kinetic energy is equal to half m into v square. Half into m into v square. Okay, this is the equation to find kinetic energy. Flowing water and flying aircraft, a rolling stone, a speeding car have energy. It possesses an energy. These objects are possess energy and they can do work for another object. So it is the equation to find kinetic energy. Kinetic energy is equal to half mv square. So let us do a problem, a simple problem. Calculate the kinetic energy of an object having a mass of 5 kilogram. Having a mass of 5 kilogram. It is moving with a velocity of 20 meter per second. This object, this car, is moving with a velocity 20 meter per second. This car only have 5 kilogram. You can change this value into a 500 kilogram. If it is a car, then it may be 500 kilogram. So there is a car having a mass of 500 kilogram. It is moving in a velocity of 20 meter per second to a road. Then find the kinetic energy of that car. Kinetic energy is equal to half m into v square. That means half into m. Half into m means 500 into 20 square. 20 square means 400. V square means 20. 20 square 400. Then 500 into 400. You can only need to multiply this 5 into 4, 20. 5 into 4, 20. Then apply 4 zeros. 1, 2, 3, 4. Divided by 2 is the answer. It is 2 lakh. So 1 lakh is the answer. 1 lakh joule is the kinetic energy of that object. Okay, it is high amount. That car only moves with a velocity of 20 meter per second, but the mass is 500 kilogram. So the amount of work this object can do is 1 lakh joule. Okay. Then the another type of energy is potential energy. The next type of energy is potential energy. The potential energy of an object is due to its position. Kinetic energy is due to its motion or its speed. The potential energy possessed by the object is the energy present in it by virtue of its position or configuration. It is the energy present in that object by virtue of its position or configuration. This object have a potential energy because I raised this object into a height. If I release it, it fall down because of the potential energy. So potential energy is due to its position or configuration. A spring have potential energy because of the configuration, because of that arrangement. A spring, the structure of that object gives a potential energy. So potential energy is due to its position or its configuration. Okay. Then potential energy of an object at a height. What is gravitational potential energy? Is gravitational potential energy is present in any object with a height from its ground state. It is the energy present in an object which is being raised to a height h by doing work against gravity. I place this object into a height h by doing work against gravity. All object experience gravity, but we want to do work against this gravity. So because of that work, this object have a potential energy. We have to find that potential energy. What is the equation for work done? Work done is equal to F into S. F into S. S means height. Here, this object is placed at this position. This is the ground state. And this height is H. So, our displacement to rise this bottle from the top side to the upside is H. F into H. Because the displacement is height, equal to height. Then what is the force? This object have a weight of W is equal to mg. We want to apply a force same as that of the weight. That is F is equal to mg. F is equal to mg. Substitute that value here. Mg into h. So this is the work done and it is same as that of the potential energy. The potential energy of an object having a height h is equal to potential energy is equal to mgh. This is an important equation. We have to do problems by using this equation mgh. Then what is law of conservation of energy? It is a famous law. The law states that energy neither be created nor be destroyed, but we can convert the energy from one form to another form by different processes. Okay, the law states that the energy can neither be created nor be destroyed. We can only convert the energy from one state to another state by different processes. A conversion process is only happening. There is no creation of any new energy. There is no creation, but also there is no distortion. How this electricity is produced? This electricity is produced by an electric generator constructed in in the side of a dam. Okay, so the mechanical energy of the water flow is converted into electrical energy by using an electric generator. So there is a conversion process. In the same way, any energy can either be created or be destroyed, but we can convert it. Here, when an object from a height, this is an object placed at a height h. Okay. When an object from a height h, then the potential energy is converted into kinetic energy. When an object falls from a height h, then the potential energy is converted into kinetic energy. I pull down this object. What happens? It will have a potential energy that is equal to mgh because it is placed at a height h. When we fall down, when this object gets down, this mgh potential energy is converted into kinetic energy and this moves. The kinetic energy is continuously in such a way that the total energy is a constant. The total energy mgh plus half mv square should be a constant. So when potential energy decreases, kinetic energy increases. When mgh is 0, potential energy is 0, that is the object will fall down. When h is equal to 0, mgh is 0, but kinetic energy is good maximum. Half mv square is good maximum, but the total value is always constant. Energy can either be created or be destroyed. mgh is converted into kinetic energy, half mv square. So total is constant. Then rate of doing work. What's rate of doing work? In the previous topic we discussed about work, but rate of doing work, it is known as power. What is power? Power is defined as the rate of doing work or the rate of transfer of energy. The equation is that power is equal to W by T. Rate of doing work means work divided by time is equal to W by T. Then what is the unit of power? Is watt. Unit of power is WAWT, watt. Okay. Then define 1 watt. We need only to substitute 1 here and 1 here. 1 watt is the power of a person who does work at the rate of 1 joule per 1 second. 1 joule per second means 1 second. 1 watt is equal to 1 joule per 1 second. Okay. Then 1 kilowatt is equal to 1000 watt. It's a common thing. Kilo means 1000. In this chapter, we studied these equations. First one, energy. First one, work is equal to F into S. Then kinetic energy is equal to half mv square. And potential energy is equal to mgh. And then power is equal to W by T. These 4 equations, these are the equations that we studied in this chapter. Okay, you want to study these 4 equations and do all problems in our chapter.